Welcome back to Element 14 Presents. I'm David, and this is an iMac G4, which is one of my favourite designed computers ever. Now, if you've been watching the electronics inside, you will probably remember when I tore this apart quite some time ago. But this never worked when I got it, and I thought now was as good a time as any to upgrade it using a NUC. Now this is going to go inside the bottom of here. We're going to replace the low resolution 17-inch display with a nice big 1920 by 1080 22-inch display, and I'm going to do my absolute best to make it in keeping with the original design aesthetic. Let's go. Well, welcome to the coding cave. So let me bring you into a little bit more detail of what the plan is from here. First of all, you've seen me tear down the iMac G4 before. If you haven't, go watch that episode. We'll put a link in the description somewhere. The electronics inside is brilliant. If you don't watch it, I don't know why. So this wonderful round monstrosity is the motherboard for the G4. And this circumference round here is where all the holes are in the back of the case, and this is where the I/O wants to be. Now, obviously we've got a load of 3.5mm jacks. There was a space here for the dial-up modem. Don't need that. There's an Ethernet port. We'll be using that. And then we've got 2 Firewire, 3 USB, and some proprietary rubbish Mac connector. So I've got a couple of USB 3 sort of upright mounted PCB mount USB ports, which hopefully we can get to match the position and the radius of the USB 2 ports on here. I've also got a display port connector, which again we can replace that proprietary Mac connector. And I've got some barrel jacks, so that'll be 19 volts in. Now the best thing is the screen and the NUC both run on 19 volts, so I can use that as a throughput. And lastly, I've got, like I said, Ethernet breakout. So all I'm going to do is create a PCB that uses sort of this arc with a straight back that I can fix down to the case, and it's going to position the ports here, and they're not going to have any intelligence on them. They're just going to be sort of breakout boards, which means I can take a lead, plug it into the back of the NUC, and then solder the leads onto this PCB, and it will just be positioned and fixed nicely on the back of the case. That's the plan. I could do much worse than taking a really good high quality front-on resolution picture of this and trying to trace it in CAD. And then when I've got that vector file in CAD, that shape of the PCBs, I can then import that into KiCad and use that as the shape of my PCB. In fact, that might be the most sensible thing I've said all day. Okay, so that's largely the power taken care of and the PCBs. So the last thing I need to worry about is the functional fit of the new screen. So this lovely LG screen is a 22-inch LED version. Now that should be significantly lighter than the LCD that's the original on the G4, just down here. It's obviously bigger, so the first thing I've got to do is remake that bezel. Now I've got some 3mm clear perspex, which I'm going to send out to be laser cut, and that's going to be a really simple shape that's going to sort of mimic the curve, and then I'll paint the back of it for the white bezel. Easy enough. The back, however, is a little bit more of a challenge. So you can see on the bottom here, this LG monitor has got this weird little joystick for controls, which weren't really necessary for the original G4. So the front bezel is going to be based on clear acrylic. I'm then going to 3D print a round profile that sort of most of the way around sort of matches that curved edge to the G4. And then I've got a white sheet of perspex, which we're going to make up the back of the bulk of it, with a little added surprise. And then we're going to 3D print the bottom, so we still have access to this joystick to turn the monitor on and off as required, and also so we have access to the on-screen menus. Hopefully that shouldn't be too hard. None of it sounds particularly challenging, but I'm sure I'll find a way to get it wrong. Now, if it's not immediately obvious, and it really should be, I'm not an expert at using KiCad. So of course I've lent on the expertise of my friends again, and I've even followed Clem's 3.5-hour tutorial on how to use it to create PCBs, and yes, I failed then and still had to give Clem a ring and ask for help. So thank you, Clem. All the resources are over on the Element 14 community, and of course we'll link all of those in the description below this video. So some time has passed and my PCBs have been delivered, and I've got to say, I'm thrilled with them. Yes, I had to ring Clem for help more than once, but I'm very, very pleased with how they've come out, mostly because of the spatial fit. So if we line up the screw holes on the bottom of the Mac with the new PCB, and it's perfect, and we're going to get these vertical USB ports soldered on, and the mini display port, which on reflection was a massive mistake. Mini display port, really small, don't work with that. So let's get some parts soldered up on here, maybe a few of the leads, and then we can start attacking the actual monitor and the build for that. Now, this board isn't perfect. It was my first try. I will share the files for this. If nothing else, it's got the template and the shape right for the mounting holes and everything that you would need to create your own board. But I will do my best to improve on this board and do a version 2, which I will share on the Element 14 community. So head over there to grab all the files you'd need. Okay, so this soldering iron is actually new to me as well, which does make me kind of nervous that this is all going to go horribly wrong. Yep, I can confirm mini DisplayPort is a horrible connector to work with. The pitch of the pins, I mean, just look at it compared to those USB 3s. Just horrible. Don't do it. Find another connector, people. Okay, so this is where we are with the base of the iMac. We have got the NUC that will sit in there, and we've got the new PCB, which really nicely lines up with mounting holes and the rear of the board. Got mini DisplayPort, USB, and I'm going to solder these breakout cables so they connect here. We're also going to have a barrel jack which is separate, which is going to connect 19 volts both to the NUC and to the screen. So let me get the cables on here and then we can move on to working out how that screen's going to work. That's a bit I'm really not looking forward to, because this has got a load of very powerful springs in it, which I hear once you open that arm are very hard to put back together. USB 3 cables, if you're not familiar, are picky. Let's put it that way. So they have the same ground and 5-volt rails that a normal USB have, or USB 1 and 2 have. They've obviously got the data pair as well, but they've also got a pair of differential pairs. Now, using the modified USB-A connector, you can sort of see in the end you've got those additional connectors and they are sprung, which is an interesting topic for a whole other video, I think. Right, let's get back onto the monitor. So this is the new 22 inch that's going to go on there. I've had some lovely laser cut parts made. First being the bezel, which fits wonderfully on the front. Obviously, where the overlap is between the actual screen and the edge of the bezel, I'm going to have to spray white or paint white from the rear, so that when I glue the 3D printed parts on, they are going to create the proper illusion like the original G4 iMac. And the other part on the rear is I've had a back print laser cut with the Apple logo on there. And once we take this out the case, which I guess is the next job, we can then work out what other structures we're going to need to fit in around this. So the good news is the little joystick is going to be relatively easy to reposition. I'll level with you, I was expecting something much more positive to affix to other than that, which actually is not a bad thing for our use. Because if we've got to work out how we're going to fix to that, and all it is just this tiny little thing, we should have some more flexibility. So let's... So the catch here is that I've got to open up this arm so I can replace all the wiring looms, because there is no way I'm going to be able to pull like a draw wire through and not open this up. But the problem is this is very heavily spring loaded, and as soon as you split this in half and pop one half off, that spring apparently fires everywhere. So I've got to be very careful, firstly with my eyes, second of all that I don't lose any parts, and thirdly that I can get it back together once I've replaced these cables with my new power and the DisplayPort cable. Well, here goes. Ah. Okay, so actually it looks like I just want to be really careful not to let that spring go. So I'll be placing that all back together and maybe taping it up just for safekeeping. Cable ties. Cable ties are the answer. The big part of this project, which is getting the cable up here, is going to fall largely down to this mini DisplayPort to HDMI cable. And mini DisplayPort to HDMI are almost passive. You need a bank of capacitors to convert from one to the other. And it's still a, 10 pair differential lines, or 10 differential pairs, I should say. And that's some challenging soldering right there. Now, this particular one has the conversion done in a little IC, a little 8-pin IC on a daughter board, which is great, but that doesn't fit through this arm. So I'm going to have to desolder this, fish the cable through, then resolder it, and then I have to worry about how I'm going to get an HDMI into the screen at the wrong angle, which weirdly enough sounds like the least of my issues. So there's that. Now I've got that DisplayPort and the power pair in there, I'm actually going to close this arm up just so it doesn't spring out and kill me in the middle of the night or something. Okay, well that was one of the bits that I was worried was going to be way more difficult than... it wasn't easy, but I thought it was going to be worse. So now I get to resolder the HDMI adapter onto the end of here.
Do you like winning free stuff? Are you an electronics hobbyist? Do you like building cool projects and winning prizes for what you build? The Element 14 community presents Project 14, the member-driven destination where you decide on the challenge. You enter projects to win monthly prizes and you vote on the winners. What are you waiting for? Join the Element 14 community so you too can enter one of our contests or submit an idea for your own. Join now!
So while the 3D printer is next door running its little socks off, I can spend some time doing the other bits and pieces, like gluing the bits that I've already printed onto the bezel. I can start working on soldering the power connectors all together to get that 19 volts to the NUC and to the screen. Make sure I got the polarities right, because I'm not sure that they were all center positive or negative positive. And hopefully, by the end, we will be in a position just to put it all together. I went for a mixture of connections here, so I've got sort of this catchy lip at the bottom. So I kind of imagine that you would put the screen in here, and then you sort of have to lift it onto the bezel at an angle, onto the stand at an angle, and then I've got clips around the top and the side. So the bottom has got this sort of lip, which I'm going to pad out with a bit of foam or felt or something along with the side, but the top has just got clips, because that just needs to snap into the bezel. So that's the plan. Now, to get this board as thin as I can, I don't really need the power connector, and I definitely don't need the VGA on it. So I'm going to remove them, hopefully using hot air. That's a much better way of desoldering big components than solder wick. So the power supply I received with NUC is this big old 135 watt at 19 volts, which is also positive center, which is good because the one that came with the screen is 19 volts positive center, but this one's only less than 19 watts. And there's plenty of overhead on this power supply to drive the NUC and the screen. So once this barrel jack comes into the PC, we'll be splitting it to take a lead up to the screen. So I've got the incoming power barrel jack, the barrel plug to the NUC wired up. I've also got the wires prepped up here and labelled ground and VCC. Now before I can actually solder them directly to this board, and I'm soldering them directly to minimise the height of this board so I can make the overall monitor assembly as thin as I can, is I actually have to pass these wires through the hole in the back acrylic. And this is definitely the first time I'm soldering this, and not at all I soldered it and then forgot that this won't fit through the hole. So I guess I have to measure and create a hole in my beautifully machined bit of perspex. And I should add, it's not even a simple shape, because this surface here is actually flush with the back of the acrylic. And you see this step of sort of 2 or 3 millimeters before you've got the actual hole. So I've actually got to create that step if I want this to sit properly, which is doable. It's just going to take a lot of finessing to get that really nice and flush. Okay, there's going to be some manual tidy up with a file, but hopefully that's got me pretty close to the dimensions of that sort of a flange. Can I call it a flange on the back? Ooh, better than expected straight off the drill. And what I might do is sort of reinforce the inside of this with another piece, and I retain that metal plate that then screwed on the front, so that's going to pinch it nice and tight. But this perspex is holding up the monitor. Fortunately, it's nice and light, and of course that's how the monitor originally came, so I figure it should be light enough. Huh? Looking a bit iMac G4-ish? So with a load of completed 3D printing, I guess the only bits left are assembly. So, montage? I don't know about you, but I'd say that I was starting to look the part. Still got to get the screen in, so it's not weighted right yet. First mating of the parts. And getting in there to plug in all the cables is going to be a pain. That 3D printing, the design, has actually snapped together really, really well, and I'm thrilled with how that's worked. So the 3D printing is mostly appalling, actually, and I'm going to chalk that up to time constraints, and each one of sort of the sections could take multiple hours to get really nice, and that's without failures and without me forgetting to tune in and look after my 3D printer properly. It's been ages since I printed anything big. But the design works really nicely, and it fits the screen and clicks together really pleasingly. So it's just going to be some design refinement. And look. To me, that looks like an iMac G4. But there's one thing left to do. Well, hang on to everything, because you're either going to see a grown man very happy or cry. Ridiculously oversized power supply. Nothing bad has happened yet. Oh. I had lights on my keyboard. Is that just the place in the boot cycle? How about the screen? Look at that. No, look at it. Come on. 22-inch iMac G4 with an Intel i3 and 8GB of RAM and an SSD, and it is very quiet. And USB 3 on the back and the front, external power brick, which is enormous. I'm chuffed to bits with that. Yes, like I've said, the 3D printing basically needs scrapping and redoing. The design worked nicely with the clip-on sides, but the actual execution of the prints just needs redoing. I like the fact the CD drawer hides the USB ports. In practicality, the ports are a little bit too far back, so I may end up looking at re-engineering the hinge, because I've just tried to reuse that CD tray hinge. Otherwise, it's kind of cool. Let's briefly talk about choice of operating system. The NUC itself came with this licensed version of Windows 10 on it, and I would ideally like to install an operating system that rhymes with Macintosh. Can I say that? But for potentially obvious legal reasons, maybe not something best done on this video. I'm super pleased with this slightly rough around the edges execution, and I hope it's at least piqued your interest. I'd love to know what you think of it and what you would have done differently. And if you have any ideas or suggestions for doing an iMac G4 build of your own using modern hardware. Thank you LG for building a monitor that was so robust I really manhandled and may have dropped once this screen. Thank you so much for watching. I'll see you in the next project. Or electronics inside. Don't forget the electronics inside.